That you've completed a lab, we're going to take a look at how to do the calculations and kind of what exactly a hydrated compound is by looking at some examples here. So what exactly is a hydrate? And again, most of this you probably picked up in the lab, but let's make sure we got everything under control here. So any compound that contains water with a definite mass in a form of H2O is going to be a hydrate. A lot of times they'll look almost like maybe like a snowflake with the crystalline form. And then when you heat it, as we know, the water leaves, and we can either have a color change. We can put the water back in, distilled water back in, and it'll go back to that original color. And also it can dissolve in water. So a lot of things we learned through the lab. It's also going to not be as ordered in crystalline structure as it's heated. And the anhydrate is a substance that is left after the water leaves. Remember when you looked at the test tube, the condensation on the test tube there was the water leaving, and what you're left with is the anhydrate. The nice thing about this, you can measure the mass of the compound before and after, and we can use that information to determine the formula. Now the formula, the naming is pretty easy. For example, if you look at these, the nickel 2 chloride, we've gone over that already with our ionic compounds. But then we just add the term here with hexahydrate, which is exactly what you would expect. So we just put NiCl2, and then we put a dot, and that dot isn't perfect. It's actually supposed to be kind of like right there, but formatting issue, and we put that 6 right there to show that it's a hexa. Same thing with this one, magnesium carbonate, penta, referring to 5. And then last but not least, again, using our ionic compound rules here, putting a dot and then putting the number 10 because of the deca, think a decade. So nothing too difficult here with the naming, but sometimes we really don't know how many waters are associated, like I said before. So we need to solve for this N right here. So there's kind of a process we can use by this, and it sort of makes sense. And I'll go through these steps here. And honestly, I'm just going to give you those steps as they are because I like to use examples to go through the steps better. But this is the sort of 5-step method you can use here. So let's break it down. So here's a question. The example question we have is we have a sample of 2.50 grams blue hydrated copper 2 sulfate. We put it in a crucible and we're going to heat it. We heat it for a while, and after we heat it, we have 1.59 grams. That's not blue anymore. It's important that we have these descriptors here, these colors, blue and white. So it's changed that color. We think that we have left is an anhydrous state right here. The water has left. So what is the formula for the original hydrate before? So all we do is we take these two numbers, what we started with, 250, 2.50 minus 1.59, and we get a number, 0.91. That's how much water left, okay? And then we're going to go ahead and we're going to take those grams and we're going to convert it to moles, because remember, moles are kind of our commonality here. We're going to use moles to kind of speak the same language when we're talking about different compounds, different elements, different atoms. So we convert that to moles of water. Likewise, we're going to take the anhydrate, again, 1.59, and we're going to convert that into moles. And now we're talking the same language here. And the next thing we want to do is find the water ratio, the water to anhydrate ratio. Anytime you want to find a ratio, whether it be moles or anything, we're going to take the bigger number and divide it by the smaller number. So these are tiny numbers, but 0.050 is a much larger number than 0.00996. When we do that on your calculator, you're going to get about 5. I don't think it's exactly 5 if I remember right, but because it's almost exactly 5, we're going to go with that. So then we're able to write that down as there's a 1 here implied, but it's not there. Just like when you're balancing equations, there's a 1 there, but we don't put it there. Copper 2 sulfate, and then 5, so that would be pentahydrate. So now we know what happens. So if you're in a lab and you do all this, and you don't know what the formula is, this is the way you would do it. Let's see it one more time. Let's use magnesium iodide. So we got 1.628 gram. It's reduced down to 1.072. Again, we're going to take those two numbers, we're going to subtract them, and we get a half a gram, 0.556 grams of water. That's what left, and it would have condensed on the test tube. We then convert the mass of water to moles. So we take what we got here, we convert it to moles. Again, do the same thing with the anhydrate. The magnesium iodide, do the same thing. And again, all this is assuming I know, remember from first semester, how to take this formula and convert it to a compound, words into formula, and then also taking those, taking that formula and calculating the molar mass. So a lot of things coming back from first semester here. And then we take this right here, we say, okay, which ones, we're going to find a ratio, so we take big number divided by small number, and that gives us an 8. And so that's the number we know to put in front of water. So Mgi2 dot 8 H2O, octahydrate, okay? So that's how you do those. Of course, there's a number of ways you really could do it. I think this is the best way in my head. Of course, everybody's different. So take a look at the example problems on the OWL, not the OWL, but the Canvas quiz. Follow these steps, do the same thing. Have your periodic table and your calculator ready to go, and give those a try there. All right? Cool. Let me know if you need anything, all right?